Alright, so I'm going to do two problems here for ice tables. The first one is going to be when we have a perfect square, so it makes things a little bit easier. The next video I will do will involve the quadratic formula. So on this one, we have the equation that I wrote up top. The K value is 102 at 500 Kelvin. And then the problem stated that we start with 0.110 molar carbon monoxide and 0.110 molar water, and you don't have anything else. And we have to find the equilibrium concentrations. So, since all of the coefficients are 1 in the problem, then all you have to do, the reactants will lose X, the products will gain X. So you're going to end up with X at equilibrium for the products and 0.110 minus X at equilibrium. So now you just set up the K equation, which is, well, I'll just write this out. You would have your carbon dioxide and your hydrogen on top. The coefficients are 1, so the power is 1, and carbon monoxide and water on the bottom. So just plug that in. You get 102 for Kc, and that is equal to x squared on the top, because CO2 is x, H2 is x. And then on the bottom, you'll end up with 0.110 minus x, also squared, because these two are equal. So now, since both of those things are squared, you can just take the square root of both sides. So you'll end up with the square root of 102 is equal to x over 0.110 minus x. Move the 0.110 minus x to the other side, and you'll get square root of 102 times 110 minus x equals x. Distribute, you'll get square root of 102 times 0.110 minus square root of 102 times x is equal to x. Get all your x's on the same side. I'm going to go ahead and take my work up here so I don't run out of space. And you'll get the square root of 102 times 0.110 equals x plus the square root of 102x. The square root of 102 is about 10.1. So when you add these two together, 10.1 plus 1 is 11.1x. And then 10.1 times 0.110 is 1.11. And then divide both sides by 11.1. You get x is equal to 0.100. So plug that in for x, you will get equilibrium concentrations of 0.0100 molar for both of these, and then 0.100 molar for both of these. And that is the end of the problem. So whenever you see both the top and the bottom squared, that's when you know you got the perfect square situation, and you won't have to use the quadratic formula.